Okay, I think we are probably good to go at this point. So we will go ahead and kick off our the webinar here for introducing EdgeWise Plant. A couple things to cover for the webinar. There's some pretty standard practice here. We have our slide. During the webinar, all participants will be muted during the presentation. If you have any questions, you can ask those in the chat. We do love the questions, and we want to see those. So we want to when we'll comment on those, the last 15 minutes of the presentation will be kind of covering questions. So we'll make sure to save some time for that to go through everything that people have asked. The webinar is being recorded, so we will be sending out a follow-up with the link and everything else and some more information in the next week or so. So definitely keep that in mind that we will be sending some information out. So today we have myself, and then we also have Aaron Evans and Ian Piggott. I will go ahead and introduce myself, and then I will let them kind of introduce themselves. So my name is Justin Domer. I'm a senior product manager at ClearEdge 3D. So I have been with ClearEdge 3D for almost 9 years, and my kind of role is managing our product line, which is for EdgeWise and Verity. It's kind of our core product line, and then we also have our other tools, Collage Site. And then I will leave it for Aaron Evans to introduce himself.
Good afternoon. Yes, Aaron Evans here, Vice President for Partner and Community Relations at InSource. Been with InSource for over 25 years. Been in industrial automation for over 40 years. I'll tell you just a little bit about InSource, take a brief minute to tell you about us. We're focused on digital transformation for industrial customers. We are 100% employee owned. And Justin, I guess, should I do that now or is that another slide?
While you're going, we can go ahead and we'll jump back for introducing Ian as well.
Okay. Well, yeah, I thought as I was talking, I would go ahead and get all of that done.
Okay.
So as I was saying, we're 100% employee owned. So we really understand that our success is tied to our client's success. We have a vision to make manufacturing and industrial customers more productive and profitable. Ultimately, we seek to reinvent manufacturing in America. We've been in business as an organization for over 25 years, and in that time, we've helped thousands of customers on their digital transformation journey. And our goal is to deliver $1 billion, it's a big number, but $1 billion in transformational results for existing and future clients, and we're well on our way to accomplishing that. We are an AVEVA Select partner, only one of 8 in North America. Strong partnerships with companies like AVEVA really enable us to provide cutting-edge technology. But our secret sauce at InSource is that we recognize that technology alone isn't enough. That's why we take a much more holistic approach that helps clients truly integrate the technology into their processes and routines as we support them for the long haul. That's what we call the InSource way. It's a proven process that really helps clients unlock untapped potential in their operations and their workforce. And with that, I'll turn it over to Ian.
Yeah, great stuff. So Ian, if you want to introduce yourself, and then we can jump to introducing AVEVA.
Thanks, Justin. Hi, my name's Ian Piggott. I'm a consultant with AVEVA on the Unified Engineering applications. Prior to AVEVA, which I've been at for some nearly 18 years now, I've spent over 30 years in industry with some of the larger EPCs. So my background is engineering design, working on all sorts of different plants, process, chemical, offshore platforms, and nuclear as well.
Okay, and let's see. Well, Ian, can you introduce AVEVA for us as well, and then we'll
sure.
go into EdgeWise Plant.
So, as a lot of you probably know, AVEVA is a global technology company. So we have, a number of R&D centers around the world. We've got over 6,000 employees. We're growing as we speak. We've got a number of SI partners, so that's and also an R&D capacity of over 2,000 people. So what we do is we reinvest about 16% of our revenue back into R&D. So there's a significant reinvestment in the R&D center. So we've got sales partners like InSource, we've got tech partners, and also 85% of our projects include what we call next gen techs, and we have a number of alliance partners. So with AVEVA, what we do is we cover all aspects of the industry. So we start from simulation and training, we go through engineering, design, and ultimately, you know, we've got applications and products that support operations and maintenance for what I'll class as the ultimate digital twin, the integration between the digital world and the physical world. Thanks, Justin.
Awesome, thank you so much. Okay, so at this point, what we'll go ahead and do is talk a little bit about EdgeWise, kind of the history of EdgeWise and what EdgeWise does, and then we will go through, you know, kind of covering our workflow and how we're going to, like what we've just created for our integration for AVEVA with AVEVA E3D design, and then we'll go into a live demo to actually just demonstrate, you know, kind of how it all comes together in the final result. So the first thing is a little bit of history here is that EdgeWise was originally released in 2011, and we've been kind of in the game for a long time. We've got thousands of users across the world. Historically, the place that we have had most of our users has been, you know, kind of in the AutoCAD, Revit ecosystem. That's kind of where we started out and where we worked a long time. And then now we've kind of are transitioning and trying to add more value for the plant and process side. So hence EdgeWise Plant. Some key components of EdgeWise are going to be the ability to automatically extract point clouds. So this image and a lot of what we'll be seeing throughout this demo is going to be 100% like initially extracting cylinders from the point cloud. And through that, we have a lot of flexibility. We can work with terrestrial data, we can work with unified data, we can work with mobile data. So we have a lot of flexibility in how we're able to automate that pipe extraction. We have a large amount of very robust semi-automated tools. And so these are also key factors. When we deal with design software and we're modeling in design software, there are a lot of restrictions when it comes to, you know, following those design practices. And the real world stuff is not perfectly level, perfectly plumb, perfectly straight. There's lots of cases where all this is something that's hard to align with, and so we try and balance that using specific tools for modeling from a point cloud. And the last thing we'll definitely cover is going to be our QA tools, which are extremely easy tools to jump into views where you can see immediately if the thing you've just modeled is a good fit to the point cloud. So we have a couple different sets of tools, and this all comes together to some really quick and easy modeling from a point cloud, and then bringing that into your deliverable software. So a couple things that we're going to do is is just kind of where we are going to bring in EdgeWise Plant. So EdgeWise Plant is kind of a new approach for us, where we're really focusing on the plant and process, kind of nuclear, marine industries. And our ability to work with AVEVA, Plant 3D, and some other different, you know, kind of industry tools out there. So we have some direct integrations, and this is kind of all tied together to our general goal of trying to have better support for those industries. And this is kind of our starting point for really pushing that much harder. As far as our integration with AVEVA, this is the thing we're going to mainly show today and kind of cover. This is a brand new integration. It was released on basically August 31st, so about 2 weeks ago, a little bit more than 2 weeks ago, and it's something we've been working on for a while. We've historically had a integration with PDMS, and then we've been working to kind of create a better version of that and take a different approach for how we work with AVEVA E3D design. Through this workflow, what we're able to do is we are going to automatically do pipe modeling. We have a bunch of semi-automated and automated tools for structure. And the overview is that we're going to export PML macros from EdgeWise, so directly from EdgeWise, and drop those into AVEVA E3D. And for the different types of exports, we will have a little bit of different things. So between piping and structure, we have different approaches. The key being that structure is fully catalog based, it's fully customizable. You can use any catalog from E3D directly, where we'll show that workflow, and then that directly translates to GenSec elements inside of AVEVA E3D. And then for piping, we're going to be doing exporting the piping model from EdgeWise as equipment. Now, the value that we're going to be kind of showing for that is that it's we tried to organize how we're importing that equipment into E3D as effectively as possible based on a lot of user feedback and trying to understand the workflow that we can really get value out of for having that as-built model, present and very easy to create. And that's kind of the key part of this is we wanted to make this as simple of a workflow as possible and efficient so that you can really get, a kickstart on your digital twin through getting these initial models as created as fast as possible. So we do have additional integration with Autodesk Plant 3D. So we'll briefly cover this, but based on the attendance for the webinar, we have a substantial portion of people who are interested in the AVEVA portion of this. And so what we'll be doing is mostly covering AVEVA in addition to what we're covering for EdgeWise as far as how EdgeWise works in general. But we will be sending out follow-up information to cover a lot more detail about the Plant 3D side later on. But we do have integration with Plant 3D, and it is going to be spec-driven for piping. And we'll, like I said, we'll send some more information out regarding that following the webinar as well. Okay, so some other key things that we want to cover just as far as kind of value proposition. So we've talked about automation for automatically finding and extracting pipes. We will kind of show how we're doing the structure workflow and some other key workflow components. But one of the things we really like to show and kind of push as a major value proposition is the QA tools. So a lot of design software, most design software doesn't have the ability to jump instantly into a view that you can just see how the points that you use to model align with that model. So this is something that we think is a really important value add to make sure that what you're making as you're making it inside of the software aligns with the point cloud information and make sure that you're getting accurate models as you're going. So that's something we really like and we think is a very important part of our workflow. And this works really nicely along with the automation that we have and the other tools we have for creating these initial models, as well as the kind of semi-automated tools for creating those as well. So that's something we'll definitely take a closer look at as we go. And then the other tool we'll show is going to be kind of covering our smart points. So this is a pretty cool tool where it goes through and there we go. It's a little slaggy. There it goes. Okay, yeah, the animation. So this is a cool function as well where we have the ability to export special point clouds based off of what we've modeled inside of EdgeWise. So this is something we really consider EdgeWise to be a middleware. And so what that means is that we are not something that we expect users to send an EdgeWise model to a customer or anything like that. We sit in between the workflow of importing the scan data and trying to accelerate that modeling process and then exporting what we've found inside of EdgeWise and what we've modeled inside of EdgeWise into your final deliverable. So what we'll focus on today is going to be AVEVA E3D design and that workflow of what we're creating. But the really cool part for EdgeWise is that it's very flexible. So I can import most types of data from a lot of workflows from point cloud data, and I can export to lots of different places. So I can go to Revit, I can go to AutoCAD, I can go to E3D design and Plant 3D, and I have these smart point exports and remainder cloud exports, these point cloud exports to kind of go with what we've imported into those final deliverables to add that level of detail that we aren't going to do directly inside of EdgeWise. So this is an interesting workflow. We'll cover this concept briefly, but just the ability to accelerate the workflow, but we aren't going to go into super high detail when we're inside of EdgeWise. So with that, we will go ahead and jump into the demo. So we will go into a live demo here, and this is going to be kind of showing the overall workflow of creating models for piping and structure inside of EdgeWise, and then we will go ahead and export that out to AVEVA E3D design. So I will go ahead and jump out of this view, and we were going to take a look at EdgeWise. So a couple things here that we have that we want to start with taking a look at. So the first step when we use EdgeWise is always going to be importing in a point cloud. So this needs to be a registered point cloud that is going through terrestrial. It can be mobile data. It's very flexible. It can be mixed data. It can be unified. It can be terrestrial with all the different scan positions. So it's extremely flexible, but we'll pass in that registered scan data, and we're going to run the EdgeWise process scans and this is going to look for cylinders in the point cloud, and this is where we start. This is actually our start point in the software. What we're looking at here is 0 man hours. This is no time other than just me putting the point cloud into the software and hitting run, and then an hour later, this is the starting point. It's something that we can really get a huge jump start into our modeling process with this workflow, because the software really can do some of the heavy lifting with getting that initial model created. And then what we're going to do for the workflow is fill in anything that wasn't done automatically. And so with any automation, there's still always going to be at least a little bit of work to kind of fill in and add anything that we may have missed, and then export that to E3D. So this is our 0 man hour mark, and the first thing we're going to do is look at those QA tools. So the QA tools are critical for verifying that what we've done automatically is right, and then also anything we've done manually. We have a part info smart sheet here. This is going to let me kind of connect and select various components that's in the 3D model, and then I have a QA mode here, which is going to let me jump into a nice view where I can see how the points that were used to create the cylinder line up with that cylinder. And so, this is a really simple view that when I'm in this view as a person, it's very easy for me to say, yep, that looks good. I can say approved, and I can go and kind of move through the model there and see what's been created and make sure that what I'm making is accurate to the point cloud. Some key things here. We are just looking at the points right now. So we will apply standard spec information to piping before we export. But for right now, we just want to make sure it's accurate to the point cloud. And there's some other nice tools where I can adjust its fit to the point cloud, things like this, to get that fit that I want. And it's just a really quick process to say approve, 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 adjust, delete, whatever I want to do. So once we've got our QA process completed, then we need to go through and we need to start filling in all of these gaps that are in the software. And this is extremely common because of shadows in the point cloud. So this is kind of one of the holes in scanning, is that there's almost always gaps and shadows and holes in the point cloud. And so this is something that we can account for very well in general, because the next tool we have is going to try and automatically fill in those gaps. But this is kind of part of the workflows. We need to fill those in. And the tool we're going to start with doing that for is EasyConnect. So EasyConnect is a pretty cool tool. What this is going to do is it's going to look at the different pipes that we've created automatically, and it's going to try and fill those in based on their diameter and their position. And it's not only doing that for the straight sections, but it's also able to do that for elbows. And so with one click, we've gone through and we've actually modeled a significant portion of this point cloud when it comes to the piping infrastructure. So and that works for diameter, many different diameters. We can go down depending on the scan data down to 1 inch, or I've seen lower. It depends very much on the scan data and what you're trying to model, but that is something where we can get really good detail and really quickly accelerate that modeling workflow. We also have some manual tools, and these are some really valuable manual tools for filling in that process. So this is everything we're looking at is what was just kind of one-click automation. The other things we have are these semi-automated modeling tools that are also very much purpose-built for extracting geometry from the point cloud accurately. So to create these cylinders that were not done automatically, we can go through and I can extract by just drawing a box around the group of points that represents the pipe that I want to extract. And the software is going to look at those points in that zone I just selected. It's going to try and figure out the best size and position of that cylinder. So it's just going through. And so without having to move, without having to change any settings, without having to do really anything other than just select these group of points, I can extract all of these things very quickly and from the same different diameters too. So it's really easy to go through, and I can sit in one position and just extract a ton of stuff. I can rerun EasyConnect if I want to, and this will actually try and fill in anything that was done automatically manually. So it actually did those automatically for me, which is very nice. But I also have a really convenient tool for manually connecting things, where I can actually grab the end of this guy right here, and I can click on this end, and now I have connected with an elbow. So it's, like I said, it's meant to be as easy as possible to generate pipe runs really quickly from the point cloud and really, go through and get your model created. That digital twin, that base for the digital twin is something we can do very quickly here. So once we've got our stuff modeled, we'll go through and we have this clean tool. The key with this is that we are maintaining as-built condition by default. So you'll see all these little segments here. These are all kind of mostly from the shadow, but what we're doing when we go and run this is we are actually maintaining as-built condition for these pipe runs, because pipe runs in the real world are not straight lines. When it's going to be 100 meters long, there's always going to be some deviation, and that can be really important when we're trying to, do fabrication or anything else. We want to know where stuff really is in a lot of scenarios. And so this is a great little example where we are actually making a pipe run that follows the point cloud. This is not a straight line. This is just what's happening in the real world, and we're representing that just kind of natively through our workflow. That's the default, is we have that as-built condition. We can change that. We can make it a straight line if we want to, but the default is just going through and fitting into the point cloud. So at this point, we've got a lot of our model done here. The thing we're going to start doing now is what we kind of consider applying our intelligence. So what we're looking at is just kind of cylinders. We're looking at runs of piping that are accurate to the point cloud, but are not based on specs yet. And so the diameter for this pipe run is going to be, this kind of number that is just based off the point cloud and some averages for the diameter and things like that. And so what we can do now is we can apply a standard. We have standards built into the software, and we can use whatever standard we like, but we'll stick with the ASME one for right now. And it's going to bump that diameter, the outside diameter here, to basically, kind of our outside diameter for our nominal 16-inch pipe. So when we export to E3D, we will have this information in the equipment name, and then the outside diameter will be the actual diameter that's defined here. And so we'll see that once we go into to E3D, but this is kind of how we deal with specs, is we're going to do a lot of the modeling, and then once we've got kind of stuff set up, then we can apply that intelligence to say, you're this, you're that for the nominal values. Okay, and so we'll go ahead and apply that globally. So this is just a quick way of going through and setting this. Now our numbers are much more kind of standardized based off of what the actual diameter for all these different specs are. Some other stuff I can do, I can grab these runs of piping and I can add layer information. This can be really useful for certain workflows, especially with what we're going to do when we import this into E3D. We can break the model up based on these and do different imports into E3D. It's in the naming convention for the equipment. So that's another way you can organize things. So just having this here can be really nice for just doing simple, kind of organization for what we're going to push over to when we go to E3D. Okay. And so the next thing we'll do is we do have a nice little tool for jumping into scanner views, if it is a terrestrial scan. So we can jump into this view. So we're going to do a couple other quick modeling things in this piping, and then we're going to export this and bring this into E3D so that we can actually see our model as actual geometry in E3D design straight from the point cloud. So in this case, I have this nice little kind of meshing view here that makes it easier to see things, but I can model from this view as well. And to add a T, it's as simple as just grabbing the end of the thing I want to connect and grabbing the other end. And so it's really easy for me to drop in stuff to actually create things. I can get rid of stuff if I want to get rid of things. And then we do have valves. These are spec driven. So it's a pretty limited list, but we can add in some basic valves here, and these will also translate into the piping run when we go. And these are more for placeholders than really anything else, like for the level of detail for positioning, anything like that, but they're great to have, and they will come in as sub-equipment when we actually export this to E3D. So, okay, so we've got our model set, and at this point what we're going to do now is we are going to, we can take a look at what it looks like when we actually have more of a completed model, and then we can go through and export this out to E3D. So just an example, this is kind of the raw demo data set. So we've taken kind of the raw output from our process scans. We haven't done a lot of cleanup here. We haven't done a lot of mixing, but with a couple hours, maybe less than a day, we can get something like this. So this is basically our model that we took here. And this was about a day for actually going through, you know, and modeling and cleaning things up and getting rid of stuff and getting everything cleaned up. So again, it's extremely fast to be able to model large projects. The value you get, you know, the bigger the project, the more value, because the more automation we can really leverage. If you're making, you know, a single pipe run, we can do that very well. But if you need 1,000 pipe runs, we're really good at that. And so, you know, we can go through and we can look at, you know, kind of that final result when we go to into E3D. So we have this here. And so to export to E3D, and I'm going to switch back to that demo data set. I think that's a little bit more, that raw look is kind of nice for seeing what we'll really see when you're kind of going through things. But this process, the way that we are exporting to E3D is we have a new AVEVA E3D macro format. And so this is going to create a .mac macro file that is going to contain all of everything we're going to make inside of E3D. So I'm going to go ahead and save this. And it's going to be pretty quick. It's almost instant. And then I'm going to jump over to E3D and we're going to import this into E3D to actually see that final result. So I have E3D open right here. And so in this workflow, I have that macro file, and all I'm going to do is I have a site that I want to drop into. And so I have this macro file. I'm going to drag and drop this macro file that I just created. And actually, I'll even pull this over just to show, you know, we just made this one from right now. And I'm going to drag and drop this. And this is going to do a couple things. So we have some logic in the macro file to kind of help. In this case, we're not dropping into a zone. So it's in a site, and it's going to basically allow me to create a zone if I don't have one already. And I can call this, you know, whatever I want to call here. And then it's very importantly going to ask me what I want the prefix of the piping name. So this is a really important thing that we, from customer feedback, that we wanted to add, which let you, you can change basically the naming convention of all of the equipment that you import right here. So if I were to just hit enter, it's going to call every single piece of equipment pipe run dash, you know, 0 through 1,000, dash the spec name, dash the pressure rating, dash the layer name, you know, any information we have in that system, or I can call it whatever default naming convention I normally use in E3D for, you know, that site, that zone, that area, that section of piping. So we wanted to make it as easy as possible for you to customize basically this import process where you can break up your model into any sort of naming convention you want, and then we can set this up for kind of the webinar. So in this case, I could do, let's see, EdgeWise Plant. And if I call it this, then when we import, all of our equipment is going to be called EdgeWise Plant in the naming convention. And the macro import is extremely fast, which is very nice. We've tested with really large, like whole oil refineries with 10,000 pipe runs, and did it in 20 seconds. So it's pretty amazing how fast it is for that import. But now, if I look at this model, this is our system. And the key that we did for the equipment modeling is we broke up the equipment based on layers and kind of based on the pipe runs that are defined inside of EdgeWise. So in this case, this single pipe run is made up of this equipment. And so these are all our things, but the naming convention follows that whatever we define for that prefix, and then whatever we have for the data in there. So in this case, pull this over, we call it, you know, ASB 150 PSI. If I add that layer name, it will be in there as well. And a cool one is going to be this position where we actually have that the valves, so we can kind of take a look at that down here. And so the same thing, if I click on this, I'm going to see just as much organization as we could fill in based on what we saw inside of EdgeWise. So in this case, I can click on this pipe run, and this is a specific piece of equipment, so a single piece of equipment. And if I expose this, then, you know, that flange that's right there, the sub-equipment, you know, the valve there, these are sub-equipment elements that are really easy to see what they are and you know, organized. We can add whatever other information you want and need to this piece of equipment to kind of give that reference information. But we wanted to make it as easy as possible for understanding like what the geometry is. And so that's how we're dealing with piping. is kind of covering this. The last thing, and we don't really have too much of an example for this in E3D right now, but we do have the ability to export point clouds, which we briefly mentioned. So Smart Points is going to export just points near the geometry. So if I want to get more detail for valves and flanges and things like that, I can export that. And then Remainder Cloud is actually exporting only points of stuff that wasn't modeled in EdgeWise. EdgeWise is not going to do things like pumps and valves and equipment. We can do valves, but pumps and other equipment, we do primarily the kind of core structure and core piping systems. And so Remainder Cloud is the ability to create a point cloud that's just the points of stuff that still needs to be modeled. And that can be really helpful to cut down, drastically on the amount of points that a point cloud has, because we just remove all the points associated with all of the piping and all the structure. And then, you're left with the things that you still need to work on in your final deliverable. Cool. Okay, so that is the piping workflow. We've wanted to make it as simple as possible. It's drag and drop. It's a macro file, so you can go and edit that macro file however you want. You can edit the naming convention. You can add extra PML at the top to add more logic to follow your workflows. It's a totally open format for you to work with, basically. So we wanted to make it as transparent as possible for that transition from EdgeWise to AVEVA E3D design. Now, the next section is going to be structure, and we took a very different approach for how we are actually working with structure, because catalogs are so important for structural steel. We aren't just making cylinders and applying that information and bringing them in to represent that position. We really need to make sure that an I-beam is an actual size of an I-beam. And so the workflow that we've taken is that we are actually able to export all of the catalogs directly from E3D Paragon and CSV files. And then in EdgeWise, we actually have a built-in function here where I can import those exported E3D catalogs, and then we will automatically generate an EdgeWise structural steel standard from the E3D spec, so that when I model in EdgeWise, it is native E3D basically components, like elements. So the steel frames that we're going to be making are based off of whatever the steel catalog is that you use. And so if you go through that workflow, you export the catalogs that you want to work with in your project, and bring those into EdgeWise, you model with those. When they are exported from EdgeWise to E3D, they will be exported just like piping as a macro export, and that macro export will be GenSec elements with the spec reference of what was defined in that catalog from E3D. So we really tried to make it as kind of fluid as a workflow as possible, so that when you import into E3D, it's native E3D geometry for all of the steel, and it just works because you're using a catalog that's part of your project. So just to kind of briefly show it, I'm not going to go to Paragon and export the catalog, but you would go to Paragon, you would select the catalog you want to work with, and you would export that as CSV files. We can kind of take a look here on what that would look like. So in this case, this is just all of the catalogs from E3D. So this is just going through and exporting each of these for all the different steel that I want to work with. I can open this, and then EdgeWise will actually let me save out a EdgeWise standard. And so I could use this guy right here and save this, and then that will be an EdgeWise custom standard for based off of that catalog for E3D. And so to switch over, I'm going to kind of jump back to structure. And this demo data set, we have a couple things created already. So this is something where these were manually created, but the key is that I can import that structure model, that custom catalog, and I've already done that. And so if we look down here, this is that custom catalog. So if I use this is going to be from E3D directly, and then everything translates. So it's really flexible, but pretty much all of these standards that are built into EdgeWise are also going to work into E3D as well as native GenSec elements. So we try to fill that out as much as possible. There are going to be some gaps, and we'll see those when we actually look through the model here. But in this case, this is an American plant, so we'll leave it as the AISC steel for right now. Now, to actually create a piece of steel inside of EdgeWise, we're going to do something very similar to what we did with piping, which is for extraction. So I'm going to say I want to work in the standard. I want to make an I-beam, and in this list is a list of all of the I-beams in that standard. And so when I go to extract, the EdgeWise is going to pull from this list and find the best sized I-beam and fit it as accurately as we can to the point cloud. So I don't need to know the dimensions of the steel. I don't need to reference any documents. I can just have EdgeWise look through the list of catalogs for steels that I think it should be, and we'll try and find the best size. And then we have QA tools to visualize that and make sure that's true. So I'm going to go ahead and hit the extraction process. And it's again just drawing a box around the group of points that represents that I-beam. And we're going to make that I-beam in here. So at this point, we have the I-beam created. And then I can jump right into the Smartsheet view and take a look at the fit. And so in this case, the software has decided that it is a W12 by 35 I-beam. And in this case, it's a pretty good fit, but I can grab this and I can tweak it. So I can move this around a little bit and make sure it's a good fit to the point cloud to get a good set there. So that looks good. And then the key here is that in E3D, I'm going to see, for E3D here specifically, as long as I see this here, that's what's going to be the spec ref in my GenSec macro file definition. And the other thing we're doing is we have the C-top, so we are defining justification to make sure that we put things in the right place, and then we set it. So if it's an I-beam and it is a beam, we're going to do center top. If I make an angle a column, it's going to be a vertical column will be center middle, and then if I do angle iron, it'll do different ones. But we try to add the logic here to make sure that when it goes into E3D, it's in the right position and kind of defined correctly for the easiest usage. So in this case, we'll model some more stuff. I'll go ahead and do an extraction. We can extract this guy up here as well. Actually, I'll do set to select. This is a really nice feature, is I can grab, I'm just going to make more of the same size, and that can be really helpful for creating stuff, but that is where we set there. And then I'm going to do a piece of angle iron just to show, it's not just I-beams. So we can do concrete columns and beams, some basic shapes there, and that will go in as panels into E3D. But if I want to do an angle iron, I'm just going to say I want to make angle iron, and then I'm going to draw my extraction box on a piece of angle iron. So it's some really simple tools. The QA is really nice here. So we didn't quite get the leg length right on the first extraction, but again, it's super easy to tweak this where I can get the leg length right. I have thicker and thinner steel tools, so I can jump between sizes, and that looks great. And I'm going to move on. So that looks good, and we can go to the next section. The last thing we'll do two things before we wrap up to put this over to E3D. We have an extend tool. And so what this will do is we have a little bit of gaps here based on extraction. I can extend to a surface. So I'm going to extend these guys here, except for I don't want to select this guy. Oh. Grab these two and extend to this surface for these guys, and then I will grab these three, and extend over here. Grab this guy, extend here, so we can kind of fill in everything. We do not do super high detail. We kind of mentioned that. So we're just going to kind of have that thing come and touch each other in the E3D, and then because they're GenSecs, you can do connections and do the slicing and everything else like very easily once you're in. But for EdgeWise, we keep it very basic for how we do that interaction. The last thing I'll show is our automation, and this can be a really useful tool for a very common occurrence in structure, which is repetition. So in this case, I have this bay, and it is repeated all the way down to the end of the system here. So for supporting everything, for all the piping we just made. And so instead of going through and extracting every single one, which would still be very fast because I can go sit here and I can extract in this one view, I could extract every one of these angle iron and I-beams. I could do a ton of extractions right here without having to move, especially if I start doing section boxes and things like that to isolate point clouds. You can move very quickly with extracting one at a time, but we also have pattern extract, which is going to try and automate that even further by leveraging the fact that there is repetition. So in this case, I want to take this angle iron and I want to extract it over there. And so what I can do is I'm going to say the distance between this column and this column, go ahead and try and find more angle iron that is in that similar spacing as these two columns. And it was really fast, but it said pass 1, 2, and it looked behind this, didn't find anything, so it stopped. And when we look at the fit here, we can double check, and that looks great. that's a good fit to the point cloud along that entire length. So we've done a good job there. And so we'll move on. And the cool thing is I can grab all of this and I can do the same thing, but instead of going across, I'm going to say the column from right to left, and it's actually going to go through and it's going to look for each one of these individual pieces of steel and concrete that we've extracted and try and fit those to the point cloud based on that pattern, and it'll go until it can't find any more structure. And so with this, we should be able to, in this case with the demo, we're going to extract pretty much everything. But this can be really nice for this use case where there is going to be a lot of repetition in structure, but we're accounting for the fact that things will be a little bit twisted or maybe 1 or 2 inches off from that exact array, and we're just fitting stuff to the point cloud, and that's the key value there. So once this is done, we're going to kick this out to E3D, and then at that point we will wrap up for the demo side and basically open things up for questions. So if we look here, this is kind of cool where we stopped where we stopped because it didn't find anything when it did this extraction. It couldn't find any more steel, so it stopped the run. And then something really cool here is that this right here is missing, but that's because it doesn't exist. So we did not extract that thing, and so that's because it wasn't in the point cloud. But if I click on one of these angle iron or these I-beams, it's a great fit to the point cloud because it is looking at the point cloud. It's not just copy and pasting, it's actually fitting it to the point cloud. We'll look at the angle iron. So angle iron, this one's a little rough just because we only have data on one side, but we can, again, really quickly adjust that. So it's super easy to make tweaks and adjustments based on the fit, especially when it's a little twisted. But these sorts of things are now just QA, and then I'm going to export this out to E3D. So same thing, just to show it, we have this this model here that's kind of built out, and we did this in like a couple hours, like 2 hours, I think. So it's really fast at going through and creating that model, and then when we go to E3D, it's going to be native components. So in this case, this one's kind of more interesting. So I'll grab this one. We'll go ahead and export this guy out to E3D. We can go and hit that same export button. And again, this is going to be a macro export. And we can save this to our folder here. Hit save. And then in E3D, I'm going to go and I have a different section. So I have a structural frame and framework. So I'm going to select the structure. And now I can grab my macro that I just created right here. And I'm going to drop it in, and it's going to create a framework for me because I don't have one. And then it's going to let me name that framework. I'm just going to hit save, and we can name it whatever you want. And it's going to import everything as native Gensex into E3D directly. So now I can click on this, and the properties are going to be based off of what we define inside of EdgeWise. So the reference is it's the American standard for profiles. It's a W12 by 35. I can switch it out with any other steel because it's kind of native components. And then we also have that justification defined correctly based on what it is. And for angle iron, in this case, like if it's a beam, it'll be center middle. But if it's a beam and it's angle iron, it'll be left top. If it's a brace, it'll be center middle. So we try to make that flexible for making sure that it kind of aligns roughly with the things that we need it to. But yeah, so this is the native components inside of E3D, and if we zoom out, we can kind of see that model. So again, this was roughly created in less than a day, this whole model, and then it's brought into E3D as native E3D components, very flexible as built conditions for what's happening in the real world. And so yeah, I just kind of end up on that. We have this kind of, it's hard to get the perspective view there to see it, but this is not straight runs of piping that are as built, and there really are kind of that base for digital twin. So with that, that is everything I have for kind of showing that integration that we've created with EdgeWise Plant for AVEVA E3D. This is going to be something where we wanted to make it very simple. We wanted to make it very fast. And the cool part is that, it's very flexible for working with EdgeWise. So we can go, we have a step export, we have a Revit export, we have a COE export, we have DXF center lines, we have PCF export. So there's tons and tons of ways for you to use EdgeWise in your workflow. So the modeling is very fast and the workflow is very flexible. But we're super excited to have the support for AVEVA E3D design. And we hope that it's something that people like. So at this point, what I will do is kind of switch over and I think we can start covering we'll go back to the PowerPoint here. One of the things that to cover that, and just to wrap back up to the question soon, is that we do have a customer. Hopefully Bob is with us here in the webinar, but so Bob was someone who we worked with in the development process, just kind of talking with him in the workflow from Wood Engineering or Wood PLC. And this was just a kind of some information that he gave us. He's only had the software for 2 weeks, but as far as the actual released version, but it's something that we hope is something that is very useful and valuable, and that makes a lot of sense for accelerating that workflow. So that is some key parts there. And let's see. I think we'll jump over to kind of the key values for EdgeWise. We're going to go through here of the ability to model significantly faster. We have very consistently see a 60 to 70% improvement in modeling time. You will save, on big projects, thousands of man hours potentially. I mean, it's something where we can really accelerate that workflow, really take that cost of creating an as-built model or a digital twin and make that much simpler, much easier, and push it over. So that is pretty much everything before we go to questions. So let's see. At this point, let me take a look at questions. And for Ian and for Aaron, that we'll kind of bring you guys back in. Let's see. Okay, so now is a great kind of questions for the workflow. Okay, so Ian and Aaron, do you have any comments on the workflow and what you've seen? Does this make sense for what you think for customers and for kind of adding that value for getting that digital twin created?
Yeah, Justin, this is Ian. So yeah, I agree with your comment about a more accurate as-built model, but it goes further than that, right? So with a more accurate as-built model, you're going to get more accurate planes. If there's a need to modify any of the structural design, you can start, and there's a requirement to add joints. You've already got the Gensex there. Also demolition drawings, if you need to create demolition drawings, there's a lot more in the model now that's intelligent to create those demolition drawings. And also, because a lot of this is sort of semi-intelligent or intelligent as well, if it affects calculations such as COG or structural analysis, it's all embedded in the model there. From an owner standpoint, we see a lot of owners now, or a number of owners, that are looking to have a truly digital twin, and you will have heard Justin mention it a couple of times. And basically, this is a foundation for the start of the digital twin journey. Bringing some of these plants that are probably 50 years old or more, in bringing that into a truly digital world. So yeah, I see a lot of benefits here, Justin.
Okay, great. We'll start from the top here. Let's see. Are elbows at this point in piping components or geometry? So that's a good question. So the way in EdgeWise, when we go through the modeling, everything's kind of different components. So we do know that they're an elbow. We know pipes are pipes. We know valves are valves. That sort of process, basically. And then when we go to, in this case, for the E3D workflow, we are bringing them in as toruses as part of kind of the equipment ecosystem in AVEVA E3D design. Let's see, so there's some questions for that. Sure, manual 3D model. So how is the equipment imported? So hopefully that's kind of covered. Basically, it's drag and drop. You select the space you want to import things into E3D. You grab that macro file, you can import it. You can also do it in command line with, I think, the money sign M, and then give the file reference, but drag and drop is very nice. That macro file is fully built out, so you can just go and bring it in. Insulated pipes, that's a great question from Bob Reed here. So this is, because we're just doing equipment for piping, it's really up to you. You can kind of manage that in different ways for like how it's actually shown. So in that case, like if we can only model the outside diameter of the pipe. So if the pipe is insulated, that's what the points show us. That's what we're automatically going to find. And so when we go through and bring those in, you can either set the diameter to the actual diameter of the piping and kind of ignore insulation, and it'll be based on center line. But you can also go through and just document that, hey, this one is insulated, and you can say, so in that layer information for the equipment inside of EdgeWise, that you can put whatever information you want in to try and help with that documentation. But as far as the actual approach, it's very flexible because we're importing as equipment. Okay, great question for, okay, so for, let's see. We do not, so for advanced steel, that was another question. We have a couple different exports, but we don't have like kind of a generic one that can go to advanced steel. We're interested in doing an IFC in the future, but we don't really have a timeline for that one right now. So there's a couple ways. I mean, we can export steel as kind of a step format, and then it'll give you generic information. But we don't have a direct advanced steel export. So cable trays and ducting. So we are able to do, we can model cable trays and ducting, rectangular ducting inside of EdgeWise. We do not have a direct export for E3D currently, and that would be based on user feedback. So if people really want that, we can definitely look into that and that approach. But for right now, the default option for going into E3D would be through STEP. We have a STEP export. We can do cable trays. We can do ducting systems. There's some really nice workflows for those. I would take a look at that in some of the YouTube videos and things we have for the software. But it would be kind of generic STEP exports to just kind of have that geometry representation. And then those are intelligent in other workflows like going to Revit. Let's see, we've got a bunch of other ones here. What's the best form to, are there any? Okay, so questions for equipment. So we are interested in doing equipment at some point in the future. It's not really on the short-term roadmap, but some way of kind of representing it. It is kind of tricky because we have so many exports that we're going into. So whenever we add something, we really got to make sure that it works everywhere, and that definitely kind of adds to the complexity. But it is something we want to do. We hope that the smart points in the remainder cloud export with the set, you can go through and take a look at that. Let's see. So a big question is why we aren't doing intelligent piping. So this is our first release for support for E3D. It's a very big ecosystem. It is something we're very new to. We've got a license of E3D, as you see. We're very excited to have that, and this is our first step. So we decided to go with equipment because we wanted to kind of lower that barrier of entry into being able to accurately get information into E3D and get the foot in the door based on user feedback and kind of the ability to work with it. We definitely are interested in creating intelligent piping, native piping, and to show that. But this is something where we can, we're interested in, but we wanted to get this out there and get feedback and get this into people's hands. And that's something we want to work on in the future to be able to support based on user feedback. And like I said, that's the kind of key is we need to understand what's really critical for people to get value out of this and this workflow. And that's how we will kind of continue to work on it. Let's see. Smart 3D Smart. We do have a PCF export. There's a question for going into Smart 3D from Intergraph. We have a couple different options. I'm not familiar with like the direct import path for that. I'm not sure if we have something that can go directly in there, but there are a lot of options for what we can do. Good. We are not able to strip out the point cloud as we go. That is something that would be pretty cool. We're interested in that, but it is something that we basically have tools that just turn the point cloud on and off really quickly to kind of see what you've done and go from there. I would love to be able to do automatic pipe steel extraction like we can do for piping. For right now, that's still kind of difficult for us to be able to do automatically, but something that we are very interested in applying, and there's a lot of new technologies coming out today that could be very useful for that approach. But that's something that we want to go through. I'm going to kick this off as well. So because we are running to the end of time, I want to make sure that we cover it. So if you want to see a live demo, and I'll keep answering questions in a second, but if you're interested in seeing a live demo, you want to see what we can do, you want to basically, you know, potentially get a trial and work with it yourself, go to clearedge3d.com/request-a-demo. This is where you can sign up right away. We'll definitely contact you, let them know you're interested in the E3D and or anything else that you want to take a look at, and you can set up a call. We can go through and kind of show you what this looks like and go through every question directly with you. So definitely check that out, because we want to hear your feedback and get this in front of you so you can try it out yourself. Let's see. So for piping, yeah, I think, you know, when we deal with piping, we recognize that, you know, the equipment piping, it's not intelligent piping. We know that is obviously, there's a lot of workflows that get a lot of value out of it being intelligent piping. That's something we will definitely need to, you know, kind of understand the workflow more and get feedback on and really kind of set that priority. But it is going to be based on, you know, kind of user feedback and what people need and what value we can provide as possible. EdgeWise is a standalone software, so it is something that you install. It's its own license. It is completely independent. You do not need to have a license of anything else. So you can run this, you can have it on your computer. One thing I want to point out that's really, you know, something that we're really happy about is the software is very simple. The training for the software is 1 to 2 hours total. So it's extremely simple. I mean, the demo that we just did for structure accounts for 60% of how to use structure. You know, we want to make sure it's easy for people to go through and use and get that value quickly. And we've had many customers on their first project save hundreds or, you know, hundreds of hours easily. On their very first project, they did 1 or 2 hour training. They went through and they brought it into their deliverable, and they saved a ton of time for usage. It really is very straightforward, and that's the default training is really just that simple. So it's something that we get, you know, we wanted to make it simple because it's something that we, you know, we're just pulling that information from the point cloud and then we're passing that over to the deliverable. Let's see. Remainder Cloud has been around for a little bit. It is not new to 5.8, so it is in there. So if you have an earlier version of EdgeWise before 5.8, you should have Remainder Cloud. I think it's been there for a year or two. It is something to check out. And oh, good. So EdgeWise only works on Windows, so we do not have the ability to run on Mac or Linux. So it is kind of in that Windows ecosystem. Let's see, any other questions? Gone through a bunch of those. So any other questions? I think we are pretty much up on the edge of our time. We will be kind of following up with these questions and sending out for, you know, for anybody who's put in questions, we will try to answer those. Thank you, Bob. Copy catalog. Oh, so cool. Yeah. So Bob, yeah, appreciate it, Bob. Yeah. So it's he's going to get a lot of value from that. So very much appreciated for the feedback and for the shout out. But yeah, I think that is pretty much everything for the day. So thank you, everybody. We had a bunch of people sign up, so we really appreciate that. It's something that we're, you know, super excited about. It's new for us. We have had a PDMS export many years ago, but, you know, really very much committed. We've got our own license of E3D, and this is step one. That's the exciting thing. This is our first release for E3D. We hope that this is going to be a lot of value for users, and we're excited to continue to improve it and to really make it so that there is a real path for bringing in that process of creating that digital twin and really documenting what's really out there in brownfield projects. So thank you, everybody. I think that is pretty much all the questions there are. And at this point, we will wrap it up. So thank you, Ian and Aaron, for joining us today, and you know, from the AVEVA and from EnSource. And we will follow up with recording of this and answering any questions. And again, if you want to check it out yourself, go to clearedge3d.com/request-a-demo. It's the big button right at the top of the website. And we will talk to you very quickly to make sure that you understand, you know, what the value for EdgeWise is, and you can see this yourself. So thanks, everybody.